So this is section 6-1, and we are finding and using interior and exterior angles of a polygon. So first of all, a polygon is a simple closed figure made up of 3 or more line segments. So simple means your pencil start and ends were in the same spot. So closed would be the same thing. So from here to here to here to here, my pen started and ended in the same spot, and this is made up of line segments, so all straight lines, and none of the lines cross each other, and these are all line segments. So we have a regular polygon. So a regular polygon is a polygon whose angles and sides are congruent. So this one would not be regular because this side appears to be longer than that side. So if this is 5 centimeters and this is 6 centimeters, it could be a polygon, but not a regular polygon. We have a convex polygon, so that's a polygon where all interior angles measure less than 180 degrees. These are all of the names of the polygons that you should know at this point. So 3-sided is a triangle, 4-sided is a quadrilateral, so on and so on. So the ones that you probably don't know are towards the end. So a 9-sided is a nonagon, 10-sided is a decagon, 11 is a hendecagon, 12 is a dodecagon, and anything past 12 is that number / gon. So if we had a 13-sided figure, it would be a 13-gon. A 100-sided figure, a 100-gon. So this is the formula that we're going to use to find the angles of any polygon. So n minus 2 times 180. So this is in parentheses. We're using the distributive property when we solve it. So find the sum of the measures of the interior angles of each convex polygon. So a decagon. So we need to know how many sides it has. It has 10 sides. So we use this formula. So n minus 2 times 180. So 10 is the n. So 10 minus 2 times 180. So 8 times 180. And 8 times 180 is 1,440. So all of the angles added up together of a decagon equal 1,440 degrees. A pentagon, again, you need to know how many sides it has. So it has 5 sides. So n minus 2 times 180, plug in the number of sides, and we wind up doing 3 times 180, which gives us 540 degrees. Then we're going to find the measure of each interior angle. So we need to know what these add up to in order to write our equation. So this has 4 sides, so we would use the n minus 2 times 180 formula. So 4 minus 2 times 180, or 2 times 180 is 360. And you probably at the end of this will start to remember, okay, well, a 4-sided figure has 360. All 4 angles add up to 360 because we're going to be using that a lot. So we're going to just make our equation. So x plus 2x plus 4x plus 3x gives us 10x. So we have 10x equals 360. Divide by 10. X equals 36. And then do we need to plug that back in? Well, it says find the measure of each interior angle. So yes, we do. So this one is 36. This one is 2 times 36, which is 72 degrees. This is 3 times 36, which is 108 degrees. And this is 4 times 36, which is 144 degrees. And you should add these all up and make sure that it equals 360. I know that it does, but if it was a test or quiz, you certainly should do that. Same exact thing on this one, but again, we need to know we're going to add all of these up, but what do they equal? So this has 1, 2, 3, 4, 5, 6 sides. So you would plug that into your formula, n minus 2 times 180. So 6 minus 2 is 4. So 4 times 180 is 720. So when we write this equation, it's going to equal 720. So I'm just basically going to add up these x's. So x plus x plus x plus x plus x plus x gives me 6x. And when I add up 2 minus 4 plus 6 minus 3 plus 7 minus 8, that's 0. So 6x equals the total that we said before is 720. Solve that and we get x equals 120. And again, we have to plug it back in. So this is 122 degrees. This one is 112 degrees. This one is 127 degrees. This one is 117. This one is 126. And this one is 116 degrees. And then we got them all. Okay, let's flip it over. So we're going to find the measure of one interior angle in each polygon. Round your answer to the nearest tenth. Okay, what they meant to say is in each regular polygon, and I have that fixed on the notes that you have. So if these are regular polygons, that means all angles and all sides are congruent. So regular. If they're all congruent, I can find what they all equal together, the sum of them, and then divide by the number of angles that I have, and that will tell me what one of them is. So I'm going to start off with this one and count my sides. So this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. Okay, so we're still using this formula. So 8 times 180, 8 times 180 is 1440. And then I'm going to divide that by my number of sides, which is 10. So that means each angle is 144 degrees. Oops. And then I'm going to do the same thing for the other one. So I have 1, 2, 3, 4, 5, 6, 7 sides. So 7 minus 2 times 180, or 5 times 180, gives me 900. So all of these together equal 900 degrees. I'm going to divide that by 7 because there's 7 angles all together. And that gives me, when I round it, 128.6 degrees. So they did say round to the nearest tenth if necessary. Okay, next part. So I am going to, so the measure of the interior angles of a regular polygon is given. Find the number of sides. Okay, so this would be like what we had up here. So if they told me what one of the angles is, how do I work backwards to find out how many sides there would have been altogether? So remember, we have the same number of angles as we do sides, but we're still using the formula n minus 2 times 180. So we're going to start with this. So the number of sides, 140, n, equals the formula, n minus 2 times 180. And we're going to solve this every time. So 140n equals 180n minus 360. So it did the distributive property there. So I have negative 40n equals negative 360. And when I divide, I get 9. So that n stands for number of sides. So if one angle in a regular polygon is 140, that polygon had 9 sides. Let's try that with this one. So we're going to do 135n equals our formula, n minus 2 times 180. Solve that. So when I do the distributive property on this side, it's always going to be 180n minus 360. So that gives me negative 45n equals negative 360. And that's going to be 8. So this one is 8 sides. And then the last one, 150, same exact thing. 150n equals, and I could just skip to the next step, 180n minus 360. So negative 360 divided by 30 gives me 12. So that would have had 12 sides. So if one of the angles in the regular polygon was 150, it started off with 12 sides. Okay, now we have something called the exterior angles sum. So if we have a convex polygon, like this picture here, all of the exterior angles will always add up to 360. No matter how many angles there are, it will always equal 360. So looking at this one, these are all exterior angles, which you can see they're all on the outside. So they're telling us to find the value of x. So it's this plus this plus this plus 6 plus this equals 360. So when I simplify that, I get 4x plus 152 equals 360. The 4x was the 2x plus the x plus the x, and then the 152 was 52 plus 2 plus 10 plus 88. And then we're going to solve that. So then this one is x equals 52. Same thing on this one. This plus this plus this plus this equals 360. So I have 1, 2, 3, 4x. And 79 plus 10 minus 1 gives me 88. So plus 88 equals 360. So here x equals 68. And on the last two questions, find the measure of each exterior angle of each regular polygon. So again, since it equals 360, I need to know how many sides this has. So a quadrilateral has 4 sides. So if it has 4 sides, then it has 4 exterior angles because the exterior angles are at each vertex. So all I have to do is 4x equals 360, solve that, x equals 90. This is easy. An octagon, since it has 8 interior angles, it will have 8 exterior angles. So 8x equals 360, solve that, and we get x equals 45 degrees. And that's it.